Monolithic architecture. In a monolithic architecture, the operating system kernel is designed to provide all operating system services, including memory management, process scheduling, device drivers, and file systems, in a single, large binary. This means that all code runs in kernel space, with no separation between kernel and user-level processes. The main advantage of a monolithic architecture is that it can provide high performance, since system calls can be made directly to the kernel without the overhead of message passing between user-level processes. Additionally, the design is simpler, since all operating system services are provided by a single binary. However, there are also some disadvantages to a monolithic architecture. One major disadvantage is that it can lead to a less secure and less stable operating system. Since all code runs in kernel space, any vulnerabilities or bugs in the kernel can potentially affect the entire system. Additionally, if a user-level process crashes, it can bring down the entire system, since there is no separation between kernel and user-level processes. Another disadvantage of a monolithic architecture is that it can be more difficult to customize and extend the operating system. Since all code is in a single binary, it can be challenging to add or remove features without affecting other parts of the system. This can make it harder to develop specialized or customized operating systems. Overall, a monolithic architecture can provide high performance and simplicity but may come with some trade-offs in terms of security, stability, and flexibility. The choice between a monolithic and microkernel architecture depends on the specific needs and requirements of the operating system being developed. Characteristics of a monolithic architecture. Single executable. The entire application is packaged and deployed as a single executable file. All components and modules are bundled together. Tight coupling. The components and modules within the application are highly interconnected and dependent on each other. Changes made to one component may require modifications in other parts of the application. Shared memory. All components within the application share the same memory space. They can directly access and modify shared data structures. Monolithic deployment. The entire application is deployed as a single unit. Updates or changes to the application require redeploying the entire monolith. Centralized control flow. The control flow within the application is typically managed by a central module or a main function. The flow of execution moves sequentially from one component to another. Some important points and advantages of a monolithic architecture include: high performance. Monolithic kernels can provide high performance since system calls can be made directly to the kernel without the overhead of message passing between user-level processes. Simplicity. The design of a monolithic kernel is simpler since all operating system services are provided by a single binary. This makes it easier to develop, test, and maintain. Broad hardware support. Monolithic kernels have broad hardware support, which means that they can run on a wide range of hardware platforms. Low overhead. The monolithic kernel has low overhead, which means that it does not require a lot of system resources, making it ideal for resource-constrained devices. Easy access to hardware resources. Since all code runs in kernel space, it is easy to access hardware resources such as network interfaces, graphics cards, and sound cards. Fast system calls. Monolithic kernels provide fast system calls since there is no overhead of message passing between user-level processes. Good for general-purpose operating systems. Monolithic kernels are good for general-purpose operating systems that require a high degree of performance and low overhead. Easy to develop drivers. Developing device drivers for monolithic kernels is easier since they are integrated into the kernel. Overall, a monolithic architecture provides high performance, simplicity, and broad hardware support. It is ideal for general-purpose operating systems that require a high degree of performance and low overhead. However, it may come with some trade-offs in terms of security, stability, and flexibility. Before learning microservices, we always know why we do not use monolithic architecture nowadays, so that it will help us to understand the microservices more clearly. Monolithic architecture is like a big container wherein all the software components of an app are assembled and tightly coupled, i.e., each component fully depends on each other. Example, let's take an example of an e-commerce site. As you can see in the example, all the services provided by the application, customer services, cost services, product services, are directly connected. So if we want to change in code or something, we have to change in all the services as well. Disadvantage: large and complex applications. For large and complex application in monolithic, it is difficult for maintenance because they are dependent on each other. Slow development. It is because for modify an application, we have to redeploy whole application instead of updates part. It takes more time or slow development. Unscalable. Each copy of the application will access the whole data, which make more memory consumption. We cannot scale each component independently. Unreliable. If one services goes down, then it affects all the services provided by the application. It is because all services of applications are connected to each other. Inflexible. Really difficult to adopt new technology. It is because we have to change whole application technology.